All right, so let me begin. Okay, so we are looking at, oh, also let me say this, that if it does freeze, I think in the other class sometimes like they would have trouble seeing the lecture notes, use the raise your hand feature, or, say something into your microphone, okay? Because when this goes full screen, I can't see the Blackboard stuff unless I minimize it. Okay, so that said, now I'll begin. All right. So again, we're looking at factor by grouping. And again, that's the technique you really want to use when, okay, you have a polynomial with 4 terms. So when you have a polynomial that has only 4 terms, that's when you really want to try factor by grouping. As here in this example. And I did go through the technique. I also posted a link to a community college's website that does factor by grouping as well. So you can have more examples and stuff. All right. So again, the first thing we always want to do is we want to find the GCF. Now, looking at this, we can see there's a non-zero constant term. In other words, there's a term with no x's in it. So that tells us the GCF can't have x in it. So because of that, we take m in our GCF to be 0. So that's what we do here, as you can see. Notice also that we have a coefficient. The leading coefficient here is 1. Well, the only factor of 1 is 1 itself. So that tells us the only common factor among the numbers, the coefficients that is, and the constant term, the only common factor here can be 1, since 1 is the only factor of itself. Hence, the greatest common factor of the coefficients and the constant term has to be 1. So altogether, our GCF is just going to be 1, as you can see. Again, I've said it before and I'll say it again. X to the 0 is not that precise to write down, but for this class, Math 104, it's okay for now. It just helps you remember that the GCF X to the 0 is, helps us remember that if there's a non-zero constant term, in the GCF, you can't have any variables. So we have our GCF here. So since it's 1, we can't factor anything out, is what I'm saying. You could try factoring out 1, but that's not going to help you. All right. So now what do we do next? Well, we have to form those 2 groups. The first 2 terms go in a group, and the third and fourth term go in a group. And I did say this last time, and I'll say it again. It's really good to have the third term as addition. So if you have subtraction, as I do here, it's really good to make that into addition as so. That's really what you want to do, mostly because it helps prevent mistakes from being made when you're putting parentheses in. If you put parentheses in without thinking, like let's say for some reason you did this. Well, hopefully you can see that distributing that negative, you're not going to get this polynomial. In other words, what you're actually going to get is this thing, which is not the same. So that's why I like to have addition here, mostly because it helps me at least prevent me from making this mistake. You do have to be careful is what I'm saying. That's why I put the red lines here. So, okay. All right. So anyway, what we do now, we form these 2 groups. Now we have to find the GCF of each one and factor it out. So we do that for the first group. Now, notice that the smallest power of x here, right, is 2. Excuse me, the smallest exponent of x is 2. So our m in the GCF is going to be 2. And again, just like in the original problem, since we have a coefficient of 1, the greatest common factor of the coefficients will be 1. So b will be 1. So the GCF of this binomial is going to be just x squared. 1 times x squared, but just x squared. So what do? We factor it out, like so. Okay? So we factor it out. Okay. So from here, and again, when you factor it, you have to divide, to see what's left over. From here, right, we get this, because you're dividing into each term. And when you actually divide, right, you subtract the exponents, as you can see. Here, they cancel, and you're just left with 2. So we get this. And, oh, that shouldn't be there. Let me fix that. See if I can erase it. Oh, no, I can't erase it. All right, it'll come into play. Don't worry. So anyway, next, we have to handle this group. Okay? Negative 7x minus 14. Good. Now, we have to find the GCF of it. Okay, that's good. Well, notice the smallest exponent of x is 0 because there's a non-zero constant term. So just like before, actually just like in the beginning, right? We can't factor out a variable. So we take m to be 0. And this is where that red line comes into play. We want the factors then of minus 7 and minus 14. And I just listed them. It's really the same as 7 and 14. But you can see that 7 itself is the biggest common factor. So the GCF of negative 7x minus 14, that's going to be just 7. But we have to be careful, don't we? The second and fourth term, they're opposite in sign. So from the second group, that tells you from the second group, you have to factor out negative the GCF. So negative 7 we factor out. That is, we factor out negative the GCF. From the second group, you can always factor a positive or negative. So we have to factor out. So we have to factor out a negative, and that's what we're doing. That's what this is saying. Because the second and fourth terms, they're opposite in sign, and so we do that. And so we have negative 7 times this. Right? We put it in front, but to get what's left over, we divide. Okay, and then we divide that into each term, and we get this. Okay, good. That's cool. Okay, so does that help us? Well, it does, because once we factored these, as in the next line, this is what we got from the previous slides. Notice that in parentheses, we have the same thing, which in this case is x plus 2. Right? The reason we form those two groups is that after factoring their GCFs, we want something in common in the parentheses, and that's what happens here. So we're going to pull that out. We're going to factor out x plus 2. So we have it in front. We're going to divide it as well, as you can see. And we divide it into each term. I know it's the same story, as you can see. And then, after the cancellation, we get this. And notice we cannot actually factor any further, mostly because 7 itself is not a perfect square. So we stop here, in other words. Okay? I mean, if instead of 7, somehow this was, say, I don't know, 9, which is a perfect square, then you would factor it. But 7 is not, so we leave it alone. All right, so that's one example. Well, I was going to have people try this one, but I figured since the notes are posted, that'd be kind of silly to do because the answer basically is in front of you. So I want to go through it then with everyone. But before we do that, let me just pause the video.